Hey everybody, just thought I'd walk you through how I was expecting you to make these primers. So first of all, you have this gene. I'll do the first gene, gene 1, which is NOP1 from Saccharomyces cerevisiae, a yeast. And for the forward primer, for both primers, I'd ask you to take 20 nucleotides of a primer from both the forward and the reverse. So this gene, keep in mind, is just one strand of a double-stranded gene. This gene goes in the order of 5' to 3'. So if I were marking the 5' and 3' on this document, I would put in a 5' here, blah, 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 all the way to the end and put in a 3' there. So you can see this is just one segment of this gene. This is just one half of this gene. All right. The other half of the gene is not shown because you can figure it out by just making the reverse complement. So I'm going to make the reverse complement for this to show you what the second strand is for both the top and the last line of this gene, because this gene has, notice as you can see all of these markers over here. So like this is 10 base pair or 10 nucleotide groupings. So this is the first 1 through 10, 11 through 20. 21 through 30, 31 through 40, 41 through 50, 51 through 60. The next line starts at 61. So this gene has a total of 1 to 961, 971, 981, 82, 83, 84, 984 nucleotides that make up this gene. And the PCR products, I want it to be full length. So this is the first. This is one strand of this gene, but because all DNA is double-stranded, the other strand, remember, goes in the opposite polarity. So the other strand starts from a 3' end and then starts making copies. I'm going to do this in the same font. So the other strand goes T and then A, C, and match it up as best I can. Sorry, the spacing is a little bit funny. So T, A, C, and then T pairs with A, C pairs with G, A pairs with T, and then there's a TT, so AA, CA becomes GT. The next segment would be C, T, G, G, T, C, C, A, T, C. All I'm doing is matching every G with a C, every A with a T, every C with a G, etc. Right? So I'm making all those base pairs. This is the first 20 of them. But because the polymerase wants to travel in the 5' to 3' direction, it's really going to be reading the bottom strand. So the bottom strand is what's being used as a template. The bottom strand is what's being used as a template, but the new DNA that's being made, or the new primer, has to start with this one. So this is what you want for the primer. All right, this segment here is what you want for your forward primer, because now as the polymerase takes this and extends it, it's going to be reading more of this bottom strand. So the other bottom strand, let's see, this is, if I'm going here, would be G, T, C, T, C, C, A, C, C, A, A, G, 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 C, A, C, C, TC. Again, I'm just matching all of these base pairs here. So as the polymerase goes on and starts to extend this template strand, right, because this is one continuous piece of DNA, the DNA polymerase is going to go, oh, now I can make a copy of this, and 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 all of them as it goes in that direction. So the forward primer to start off the polymerase is this segment here. It goes 5', and I'm just going to copy and paste from the segment, the first 20, right? So the forward primer is always going to be the first, all of the first bases from the beginning of the gene. The reverse primer is a little bit trickier. So this is the end of the gene, and because there's 10, 24 there, what I'm going to do is just make the other copy of this bottom strand here, of this bottom part of the gene. The whole gene is double-stranded, but I'm just showing you the double-stranded part for here and down here. So the double-stranded part down here is T A C T C T T C G C C A C T T C T T T A T T. Notice that the end of the gene, right, this whole gene as it's written from the database starts from the 5' and goes to the 3'. So the complementary strand that I'm making here has opposite polarity. So this opposite strand that's paired to this one, if this end is 3', this end has to be 5'. So that means this end has to be 3'. So this end is 5'. So you can see how these two segments line up. A pairs with T, T pairs with A, G pairs with C, A pairs with T, G pairs with C, etc. If this top strand is 5' to 3', the bottom strand has to be 5' to 3' in the opposite direction. So as you're making the reverse primer, you know that the polymerase wants to extend from 5' to 3'. And if it were still reading this top strand, it would say, oh yes, 5' to 3', I'm going to go here, and then it falls off the end of the gene. So that means that when you're making the reverse primer, you want the polymerase to be able to extend in the 5' to 3' direction, going back into the gene. So it can read this, and then read the next strand, and then read the next strand, and then read the next strand, right? Going all the way back through the gene. So as you're making your reverse primer, you want to be this one. So now it's using this as the template, right? This is now our template. And the polymerase is now going to read this part. So it's going to read 5' to 3', right? So there's 4 plus 10 is 14, 15, 16, 17, 18, 19, 20, right? 5' to 3'. So as I'm making this primer, this reverse primer in the 5' to 3' direction, it's 5' and is the reverse complement of this. So I'm going to, if this is the forward, this is the reverse. So it's going to be T, T, A, T, 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 C, T, T, C, A, C, C, G, C, T, T, C. So this is the 5' end here that has TTA is going to match up and base pair with the AAT, right? TTA matches with the end of the gene, TTA, just like this one, TTA. So it's reading this one in reverse. So this is one way that you could have made this reverse primer for this gene, either using 5' to 3' from left to right, and you're reading the reverse complement strand 5' to 3' left to right. Or you could have also given it to me in this direction and just made the base pairs this way and not reversed it. Notice that this sequence is still the same. It's still 3' TAC. Sorry, this one has too many things on it. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. So if it's 20 long, then it's going to be CTT, CGC. If I'm reading the 3', CTT, CGC, CAA, ACT, CAA, ACT. So this is doing it manually from the end of the gene. Let me show you a different way to do this with the second gene. Gene 2, again, if you're taking the first 20, this is your forward primer. So I'm just going to copy and paste that, and I know that this forward primer is going in the 5' to 3' direction. Now I know that for the reverse primer, I want to use the last 20 nucleotides of this gene. So I'm going to take these 4 plus 10 plus 6. 1, 2, 3, 4, 5, 6. So I know that it has to be related to that sequence. But what I'm going to do instead is put it into something that will reverse complement it for me because I'm lazy. So I'm going to open up another tab and go to reverse complement. Just by typing in reverse complement, hey, look, There's a program that can do it for me. So I have this sequence that I've highlighted, the last 20 nucleotides. And what I want to do is find the reverse complement of this sequence. So I'm going to get that out of there and paste my sequence in. And I have a couple of options. I want the reverse complement. So I hit submit. Here's my reverse complement. And it tells me that it's 20. So that means that I've gotten the right number of them. So I'm going to put it back in here and let's see if it fits. Notice that this, I typed it in from this direction, right? With the ATGG was at the very last end. This is my 3' end. So ATGG, this is my 3' end. So that means that my complement of this, CCAT, CCAT. If this was 3', that means that this has to be 5', and this has to be 3'. Yeah. Gene 3, let me do it again. I'm going to do the first 20. That is my forward primer, and I put in my 5', the 3' direction there. And I'm going to take my last 20. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. I'm going to copy and paste this into my reverse complement program. I'm going to choose the reverse complement again and submit it. Here's my new 20 nucleotides. Copy and paste this here. Let's check and make sure. I know that this is going to be my new 5' end, my new 3' end, and let's make sure that this 5' matches this 3' end. T, T, A, G, C, T, T. T, T, A, G, C, T, T. Looks good. So that means I'm all set. That is how you do it. Post me your questions. Email me questions if you've got them. Good luck.